Now I am starting. Okay. So welcome everyone. So I'll start the class. So this is the first question. That question came in GATE 2017 examination. This is question number 25. Okay. So in this question, we are asked to find out this particle X, and a nuclear reaction is given to us. Right. So see this nuclear reaction first of all. Here the carbon isotope combining with electron neutrino to give nitrogen and a particle which we don't know, and we need to identify this particle. So first of all, what you need to do, just check some quantities like atomic number, mass number, that are conserved in left hand side or right hand side or not. So this is a electron neutrino. Okay. So in the last class, if any one of you have joined my class last time, so they might have known that I have talked about leptons. So there are six leptons: electron, neutrino, muon, neutrino. This is tau, and it's tau neutrino. They have lepton number is equals to 1. Okay. So in left hand side we have electron neutrino. So it has lepton number 1. So to conserve it, we should have an electron here, so that the lepton number value will be balanced on both sides. So that is why the correct answer is electron. If you want to see, you can see like 3c6 plus electron neutrino, and this is nitrogen plus electron. So you can see atomic number is balanced on both side, and also mass number is balanced on both side, and lepton number is also balanced on both side. So the answer is electron. I hope this question is clear to everyone. I'm moving to the next question. This question again, same year 2017, and this question came for 2 marks. And it is a very straightforward question. If you have studied about shell model, then you might have known this filling of sub levels. There are sub level like 1s 1 by 2, 1p 3 by 2, 1p 1 by 2, 1d 5 by 2, something, these shell levels. I exactly don't know the order after 1p 1 by 2. So there is ordering of it. So I don't know the order after 1p 1 by 2. Anyways, let's just see this question. This is carbon, like again 3c6. So this carbon has protons. How many protons it has? 6. So they are even in number. So when they are even in number, so they will couple up to give total angular momentum due to proton 0. Right? Now we have neutron. So neutron is 13 minus 6. Okay? So this is 7. So this will decide the ground state of the J and P value of ground state of carbon nucleus. Okay. Now coming back to this filling of sub levels. So in this sub levels, it can, this is 1s 1 by 2, right? So this 1 defines principal quantum number. This s corresponds to the orbital angular momentum. That means L is 0. And this 1 by 2 is total angular momentum. Okay, total angular momentum. And this total angular momentum is a vector addition of L and S, right? This S is spin angular momentum. Now when you see this case, L is equals to 0, S is equals to 1 by 2. Why S is 1 by 2? Because neutron and proton both are fermions with spin 1. So you will get Z is equals to 1 by 2. That is why we have 1s 1 by 2 state. Now take the other case when L is 1 and S is 1 by 2. So J can have two values, L minus S, and the other one is L plus S, right? 1 minus 1 by 2 is 1 by 2, and other one is 1 plus 1 by 2 is 3 by 2. So we have 1p 1 by 2 and 1p 3 by 2. These are two states that are defined here. And how many neutron and proton it can accommodate? It will be 2j plus 1. So that means 1s 1 by 2 will accommodate 1 by 2 plus 1, 2 neutron or proton. And 1p 3 by 2 will accommodate 2 into 3 by 2 plus 1 is equals to 4. Okay. Now just start filling these sub levels. I don't have a space. I should go there. So 1s 1 by 2. That means 2 neutrons, sorry. 1p 3 by 2. You should be aware of these ordering. Huh? This should be 4 and 1p 1 by 2. That means last one will go in this sub level. So now you can see here the total angular momentum is in this subscript. So it is 1 by 2, right? Total angular momentum is 1 by 2. And how you will define parity? You know the parity is minus 1 raised to the power L. L is orbital angular momentum. So you might have known these SPDF levels. So for S, L is equals to 0. For P, L is equals to 1. For D, L is equals to 2. So here we have P, right? So for this, L will be 1. So minus 1 raised to the power minus 1 is uh, minus 1 raised to the power 1 is minus 1. So the answer will be 1 by 2 minus 1. I hope this question is clear to everyone, right? Any doubt in this question? I mean, this is quite a straightforward question. Just you just need to fill these sub levels, and the ordering of it matters a lot. If suppose you have put one p one by two before one p 3 by 2, then your answer will be wrong. So you have to be careful about this ordering, and and it came out from shell model. Now I'll go to the next slide. Next question. This is again 2017 question. GATE 2017 question, question 45, and this is of 2 marks. I, I think this is of 2 marks. We'll do this question. First, I will read this question. The pi positive decays at rest to mu positive and muon neutrino. Assuming that the neutrinos to be massless, the momentum of neutrino is. You need to find out the momentum of neutrino. This. And the unit should be MeV by C. Okay. Now, first, it is given that pion is decaying to muon and muon neutrino. Okay. And we are asked to find out the momentum of this. So, what we will do? You know that Q value, the amount of energy emitted or absorbed during a nuclear reaction, right? So Q value can be defined in two ways. One is mass of reactant minus mass of product. This is one way. And the other way is kinetic energy of all the products, right? This is the other way. And you know what? We will use these two formula to find out the momentum of neutrino. So see how this is done. Right? First of all, use this part only. This part of the formula where Q value is mass of product. Mass of a product, m pi minus this m mu, right? So you need to put the values of these, and it is given to us. It is given to us, right? So it will be 139, because if you see in the unit MEV by c square is given. So c square will cancel c square. So we just need to subtract 139 with 105. You have to be very careful with the units here. So it will give 34. Okay. Now I got to Q value is 34. Now I'll explore this part of the formula where Q value is equals to kinetic energy of products. I'll write the kinetic energy of products. This is for muon. The kinetic energy will be P square muon C square plus M mu C square 4 minus M mu C square. Okay, this is the kinetic energy of muon. You know the total energy formula. This is the total energy formula. P square C square plus m square c4. So from this total energy, we have subtracted the rest mass energy. So this is total energy. From this, we have subtracted rest mass energy to get kinetic energy. Because total energy is equals to kinetic energy as rest mass energy, right? So the kinetic energy of mu will be total energy minus rest mass energy. So this is rest mass energy m c square m mu c square. So this mu in subscript, okay? Huh, yes. Huh. Yeah. Huh. Abhi, okay. So I will write. I will write. So here, then kinetic energy of no. Q value for Q value. This is the general expression for Q value. It will be mass of reactant minus mass of product, and it in terms of kinetic energy, it will be equal to mass of all the products, not reactant. Reactant won't count in Q value. So here, the next is kinetic energy of this muon. So what will be the kinetic energy of muon? Sorry. What is this? Neutrino. So neutrino is a massless particle. Okay? Neutrino is a massless particle. So if you put this here, p square c square plus m square c4. So this is rest mass. So rest mass of this neutrino is zero because it is given it is a massless particle. So the kinetic energy for it is Pc, just like as photon in the last class, if you remember. So here it will be P. Subscript is quite mu c. Okay. This I have written Q value in terms of kinetic energy of products. Now Q value I know the value, it is 34. And one more thing, conservation of momentum. Conservation of momentum. So it should be pi positive is equals to pi mu positive plus pi v mu, right? The linear momentum of left hand side should be equal to the linear momentum of right hand side. And in the question it is given that the pi particle decays at rest. That means it is at rest. So it will be 0. What you infer from this information? You infer from this information is the momentum of muon and muon neutrino is equal and opposite in direction. That means the magnitude is equal, but they are opposite in direction to conserve the momentum is equals to to conserve the momentum, because in left hand side we have pion which is at 0, sorry, that momentum is 0. So in the right hand side the decays product should have equal and opposite momentum. Okay, this is the vector addition kind of a thing. So what you get from this line, the pion positive decays at rest, that p pion muon, sorry, linear momentum of mu positive is equal and opposite to linear momentum of its neutrino. The magnitude will be same, but it will have opposite direction. Why? To conserve the momentum, because in left hand side the pion is at rest. Now put this value here. We have, I have to write this value, this is this value, huh? Then we have this value, rest mass. Rest mass of it is given to us, now rest mass of it, this is given 105. So I'm writing 105. Okay, see, the rest mass of it is given to us muon in the question itself. See, and you have to be very careful about the unit. Mev by c square. So c square and c square will cancel and we can write it 105. Okay, p nu c. Hmm? No doubt. Now I need to find out this value, this value. So I'll take this value this side. Now it is 34 plus 105 minus p nu c is equals to term in under root. Right? Now here if we look, this will be 139 minus p momentum of neutrino and is equals to this p square, it was muon, right? C square plus m muon square c4. So if this is under root, I'm taking it to the left hand side. So it will be 139 minus p mu c square, p square mu c square plus, this is just simple mathematic. C square plus m mu square c4. Hmm? And now one thing is there, this will cancel. Any this these two term will cancel because I have just told you that the momentum of neutrino will be equal to momentum of muon. So that's why these two term will cancel, and this is 139 into 139 minus, the this term, because it is given in the question, this term, right? So this will be 105 into 105. This I am taking to the right hand side. 139 will be equal to 19321. This will be 11025. If I am doing any calculation mistake, please remind me, huh? This will be equal to 278. 278 p mu c, right? Yeah. 1051. I'll tell you. See, if you see here, you are given the rest mass of muon. Ye. Rest mass of muon is given to you 105. Okay? And see the value here. It is MeV by C square. Okay? So here you see, here, this is M mu C square whole square, right? And what is this value? This value is rest mass, right? This value is rest mass. So when you put your rest mass value 105, you need to see the value, you need to see the this unit also. Okay, this c square cancel, what we are left, 105 into 105. Got it? Okay, okay. See, if I'm doing any calculation mistake, tell me, huh? 8296 it will come. Now this we need to find out, not P. We need to find out PC. Reason I'll tell you. 278 it will come. Now what will be 8296? It will be 29.84 MeV. Now I'll tell you why we have not taken this C to the denominator, because in the question to you it is asked you need to find out the momentum in MeV by C, right? See the unit MeV by C. So what you will do? You will take this C to the denominator and you will get 29.84 MeV by C. See, units are playing a main role here. So here also you can see that you have asked this question to me 105 into 105. Why? Because if you write it in this way to this value, m square C4, right? And this is rest mass. And see the unit of rest mass also, in which unit rest mass is given to us. It is given to us in MeV by C square. That means C square will cancel, and that will be this. I hope this question is clear to everyone. Everyone, I'll again repeat this question because this is one of the important question. So I'll again do this question. Means orally, I'll do this question. Here we were given pion which is decaying into. Can I change this? And shift it to blue. Okay. Here we are given this pion. See, pion. It is decaying into muon and muon neutrino. Okay, this pion is at rest. If this is at rest, so the momentum of pion before decaying is zero. Okay, this pion decays at rest, so the momentum on the left hand side is zero. So we need to conserve the momentum on right hand side also. So that means the muon and muon neutrino, they have equal and opposite momentum, linear momentum. They have momentum that is equal in magnitude but opposite in directions, in this way, like, so they will cancel each other because direction is different. That means the momentum of both of them are same in magnitude. This is one of the information that we are getting from the first line of the question itself. Now the next is we have used the q value concept. In q value, the q value have two formulas. One is mass of the reactant minus mass of the product, and the other one is kinetic energy of all the products. So we have used first one, mass of the reactant minus mass of the product. So mass of the product, why we have not included neutrino? Because neutrino are massless particle. So we have only two. This is pion minus muon. So 139 minus 105. Why I am not including c here, c square here? Because c square will cancel each other, because muon and pion masses are given in terms of MeV by c square. So I'll get 34 value. Now use the other part of the formula. MeV. MeV. Because 139 MeV by c square this is also MEV by C square. It has C square outside. So C square cancel. So it will be MEV. Okay. Now I again use the concept of Q value. 34 is equals to kinetic energy of the products. So the kinetic energy of the product will be for muon, and for muon neutrino you have to write the kinetic energy, and it is written here. So this is written here. Okay. And this is kinetic energy of this neutrino. Now, uh, kinetic energy of only products. Yes, it because in left hand side if you see, these are this is at rest. So obviously it will have zero kinetic energy. Mm-hmm. Alpha particle. There is a product, so alpha particle, and there is one product. Okay, alpha decay generally happens because the decay generally happens because your this sorry because your nucleus is very massive. Nucleus is massive. Okay. So that decay generally happens. So you have one, suppose there is, I'll take the example of any Z. Okay, I'll do it here. So this is Z, Z, X, A. It is giving 2He4. Hmm? So then it is at rest and it is decaying to give this Z minus 2, X dash, A minus 4. So obviously this is massive. So this will be more energetic, right? 2He4 compared to this one, this nucleus. And there is one derivation also of alpha decay. By kinetics, we do like mass of reactant minus mass of product something. Then again we use the same formula, kinetic energy of the product, because this reactant is at rest. So obviously kinetic energy of reactant won't count in Q value. So from there we generally found one formula of momentum of alpha particle and momentum of nuclei also. So that alpha decay is different part. I'll take the question of alpha decay in the later on classes. Okay. Now I think this question is very straightforward because this is just calculation part. So I think this question, such type of question generally comes in exams, especially for 2 marks. That is for sure, because I have seen the trend of gate examination, and such question for nuclear and particle physics always comes in exam of 2 marks, especially for 2 marks. Okay, okay. So, okay. Thank you for asking this question, first of all. So, basically, I'm working on semiconductor devices. So, I'm doing PhD in IIT Bombay in physics department. No, no, no. I've joined in 2020 January. Okay, so you are interested in research work. You are interested in PhD. Okay, okay. So you have completed your MSc. Okay, okay. Fine, fine. Yes. Haha, I can. No, no, I didn't give gate. I qualified CSIR JRF. So so my rank was 112. It was in 2018 December. I gave 2018 December JRF exam. Okay. Hmm. Okay. Actually, you should be very means you should have a strong hold on your basics. So I just did this question by taking two formulas and that are basic formula. You'll find this formula everywhere in every book. So just use these formulas and do each and every question by yourself. So this question was straightforward, but there are some other questions in which they will ask you three particles in the product side. So that will be complicated and that I'll take in the later classes. So okay, okay. Mhm. So you can drop your mail ID in the comment box. I'll share you the notes. Okay. Okay. I'm moving to the next question. This is again GATE 2017, question number 55. This is again came for 2 marks. These questions are very straightforward questions. In this question, it is given positronium is an atom made up of an electron and a positron. This is made up of electron and positron. Given the Bohr radius for the ground state of hydrogen to be this, the Bohr radius for the ground state of positronium is, you have to find out the Bohr radius for the ground state of positronium in angstrom unit up to 2 decimal places. Now in the question, just mark the keyword. What is keyword? This is Bohr radius. In examination also, you should also do the question in same way. Read the question first, okay, two times, any times you are comfortable at. Then mark the key term. Like this is Bohr radius. So we have to find this. So we should know the formula for this Bohr radius. So the formula for Bohr radius is 4 pi epsilon naught h cross square, sorry, z mu e square. This is the general formula for Bohr radius, which we generally derive in atomic and molecular physics. In fact, atomic and molecular physics starts with studying about hydrogen atom and its spectra. It starts with this. So this is the general formula for Bohr radius. Now, you know, for hydrogen atom, for hydrogen atom, we have electron and a proton. Okay, so this effective mass 1 upon me upon 1 upon proton. So I'll take LCM of it, mp plus me, right? This will be, if you see here, mu will be me mp upon mp me. The mass of proton is 1876 time of me, so it is very much larger than electron. Hmm? So in the denominator what we will do, we'll do it mp, because mass of electron is very less compared to proton, so this mp will cancel. So that is why in hydrogen case, hydrogen atom I'm taking, hydrogen atom, in hydrogen, effective mass is equal to mass of electron. This is the hydrogen atom case where effective mass is equals to mass of electron. But here what is given to us? It is positronium. So in positronium we have one electron and one positron. And this electron and proton, this electron and positron, they are equal and opposite particle. They have same mass. So what you will do here in effective mass, we have me positive upon me positive. That time it was proton, so we have just made this we have in denominator we have replaced mp plus me by mp, but now you cannot replace it because both have same mass. Electron and sorry electron and positron both has same mass. So what you will write here, because same mass both have, so it will be me by 2. Okay, put this in the formula. Can I have, no, I don't have space. So put this in the formula. A naught is equals to 4 into 3.14 into epsilon naught. What is the value of epsilon naught? 8.85 into 10 raised to the power minus 12. H cross value is how much? 1.05 into 10 raised to the power minus 34 square. Okay, Z is 1, and mu is me by 2. You know me 9.11 into 10 raised to the power minus 31 into e square. What is the value of e square? 1.6 into 10 raised to the power minus 19 whole square. Now this 2 will go up. There you will replace mu by me by 2, right? So this 2 will go to the numerator. So I'll write here. You will get a naught is equals to 8 into 3.14. If I'm doing any mistake in the calculation, please tell me, huh? You should also do this calculation with me side by side. This will be 10 raised to the power minus 80 upon 9.1 into 1.6 into 1.6 into 10 raised to the power minus 69. So we have where my ink. This it is there. So we have 245.2 into 10 raised to the power minus 11, because 69 will go above, so it will be minus 11 divided by 23.296. 23.296. So it will give me 1. Ha, ha, ha. Yes. It is 10.52 into 10 raised to power minus 11. You will take this point to the left hand side. So what you will get? 1.05 into 10 raised to power minus 10. And you know this 10 raised to the power minus 10 is angstrom, right? So the answer will be, where is the answer? 1.05 angstrom. 10 raised to the power minus 10, I am counting in angstrom because it is given. You have to find out the value in angstrom. Okay. I hope this question is clear to everyone. See, this is the question of 2 marks, and you can see if you know the, but there is a trick. It is given positronium. So if suppose if someone has read the question and they're like, okay, what we need to do, we need to put just m value here, because m is equals to me. Generally in hydrogen atom, m is equals to mu is equals to me. Effective mass is equals to me. So they'll do the same mistake here. Hmm? But no, there is a trick, because it is given positronium. And positronium, it is clearly given that electron and positron. And electron and positron both have equal mass. Both have equal mass. It's not proton. Because in case of proton, proton has higher mass than electron. So that is why in this case, mu is equals to me by 2. Not like hydrogen case, where mu is equals to me. So this is this question. This came in GATE 2017 examination. Now I'll move to the next question. This question I have taken up in the last class, but there was some problem. One girl asked me the doubt. I hope she has joined. Yes, yes, yes. I can. Yes, your voice is breaking. Mm-hmm. Huh. Say. You can share the link in the comment box. I'll read it, and I'll reach to you. I'll mail you. You can also drop your mail ID so that I can reach you. Okay, thank you. Thank you. Oh, yes. So in this question, I'll read it. It is 2020 examination question. I mean, this year it came. So the certain wave function of a particle. So there is certain wave function. Particle is there and its wave function in one dimension, 1D infinite well. They are talking about 1D infinite well. Okay. Of size 2a. 2a is the size given to us. At certain time is given. So phi x is given to us. 1 upon root 6a root 2 sine pi x by a plus root 3 cos pi x upon 2a plus cos 3 pi x upon 2a. You need to find out the probability of particle in n is equals to 2 state. N is equals to 2 state. So at time is in percentage, you have to find out the probability. Now you can see here, in 1D infinite well, the wave function is given by root 2 by a sine n pi x by a. And this n defines the state. Like if it is n is equals to 1, then the particle is in n is equals to 1 state. And if it is 2, then particle is at n is equals to 2 state, right? And if it is 3, and the particle is at n is equals to 3 state. But there is one twist here. Again, there is one twist. So this wave function is applicable when the infinite well has size a. When the infinite well has size a, then this wave function has this form. But in your question, you are given that size is 2a. So that means this will change to, where is this will change to 2a sine n pi x upon 2a, right? Here in this wave function, see clearly, very clearly, this is n is equals to, this is n is equals to 1 state, right? This is n is equals to 3 state. This one is n is equals to 2 state. Any doubt? This state is n is equals to 2 state because I am multiplying 2 in numerator and denominator, because the size is 2a, it is not a. So it is 2a is the size, and I am multiplying in numerator 2, and this will define n is equals to 2 state. So we need to find out the probability of this state, right? So the probability of this state will be equal to the oh, no, sorry. Now what you need to do, you need to first normalize this wave function. First see whether this function is wave function is normalized or not. If you see here, 2 plus 3 upon 6a, 1 upon 6a is equals to 1. So if you see here, you will find a value, a factor is there. So if you multiply this whole wave function with root a, I'll multiply this whole wave function with root a. Phi is equals to, can I change? Okay. Pi x is equals to root a, root 6a, root 2 sine 2 pi x by a plus something something something. Huh? Now if you do 6a, 6a will be same. Inside you have 2 plus 3 plus 1 is equals to 1. Now you will see 6a by 6a is equals to 1. So that means this is the normalizing factor. You should write root a. I'll change color. So the wave function, now we have root a upon root 6a. We only need to focus on this part, because the other part we are not asked in the question. We are asked to find out the particle state in n is equals to 2 state and the probability of it. Okay, so we need to find out this. So you know very well the probability will be the term, the coefficient that is written here, that is written before it. So this will be the probability. Sorry, probability is equals to c1 square 2 a by ca, this is 1 by 3. So 100 by 3 is equals to 33% will be the answer. And why this? Why I'm squaring the term which is written before it? I'll tell you why. Because any state phi in quantum mechanics can be written as a linear combination of state. So in this case, you were given like this, right? You were given three stages: n is equals to 1, n is equals to 2, and n is equals to 3 states, right? And you were asked to find out this coefficient C2, the probability of finding the state, the probability of finding the particle in this state. So that means this coefficient, right? So what you will do? So same way, phi 2 C3 square, phi 3 square, right? So phi n x is equals to C1, sorry, Cm. I'm just doing summation of it. So phi m star phi n square is equals to 1. So now this will be, when m is equals to n, this will give 1 value. When m is not equal to n, this will give 0 value. So do here the same way. So you will get, when m is equals to n, cn, sorry, this is not, is equals to c. If m is equals to n is equals to 1, suppose, so c1 square. If m is equals to n is equals to 2, then is equals to c2 square. If m is equals to n is equals to 3, then it is c3 square. So you are asked in this question this c2 square. So same way, c2 is what? C2 is this value, right? The coefficient that is written before it. So this value, this is 1 by 3, it came 1 by 3, and you are asked to find out the percent. So 100 upon 3 is equals to 33%. Clear, everyone? Okay. Then I'll end the class here. First of all, what is your name? Who asked me the question? Harish. Okay. Let me go there. You have written your. Wait. Yes, yes. Okay. Let me take the screenshot shot of it. One link. Hmm. 1D problem. Okay. And your mail ID is um, Amit also has given me his mail ID. Can I take this? If you are interested, yes. Okay. Let me see it. There is one mail ID. Uh, just Harish. Okay. One is those students who have given me their mail ID. I'm just taking their mail ID. This is my mail ID. Okay. Naveen has also given me his mail ID. Huh. Okay. See. One more is Naveen. Your mail ID is naveen.517y2 at the rate SL mail, right? SL mail. Okay. Now one girl is Chaudhary. Telegram group is nice. We can make Telegram group so that there I can share notes with you all. Telegram group is a good idea. .me. Okay, okay. Yeah, that is why I have the confusion. So .me, right? Okay, okay. So all of you will be appearing for net or gate. So net examination was over, right? Uh, how was the net examination this year? So it generally it was in 16 December, right? No, no, 16, no. When was the net exam? JRF, CSIR, JRF examination. Okay. Net, you have not. I use it. Just practice each and every question. That will sharp your mind and in a way in question. GATE examination is all about speed. If you compare the level of GATE and other examination, you'll find that in GATE examination it's more about speed. But in CSIR examination, in paper, you just need to solve hard questions. So CSIR examination will test your brain capacity. No, GATE examination will test your speed, because generally questions are straightforward in GATE, but you need to focus on your speed. So practice more and more questions so that you are able to finish the question in 3 hours. So 3 hours is a time, right? So you are able to finish 65 question in 3 hours. And in CSIR examination, it's more about conceptual questions. They are quite difficult, TIFR and just question. So if you are preparing, then prepare hard questions so that if you are getting an easy question, you will be like, okay, I can. Okay, okay. I'll try to solve, and if you want, you can make telegrams. Yes. Hello, can you hear me? I can hear you. Your voice is breaking, but anyways, you can say what you want to say. Hello. Yeah, I can hear you. Yes, you have doubt. No, no, you were asking something. Yes. Say one girl is asking question. Uh, so I have recorded previous lecture. So I have recorded the previous lecture. Yes, Mehak Preet, right? I can hear you, Mehak Preet. Hello, Mehak. I have. Hmm. Huh. Hmm. So you need previous videos, right? I have recorded previous videos. So recording is with me. So if suppose you are making Telegram channel, I can provide you recordings. So you don't need to. Okay, okay, fine. So I guess if anyone has any doubt, they can ask. Otherwise, we will end this meeting. So it's nice talking to every one of you. You guys look very enthusiastic. Yes, Harish. Telegram. Okay, I have your mail ID. I have mail ID of all of you, so I'll send you. Okay, I have noted down. Oh, okay, okay, okay. Anyway, you guys are comfortable at. Okay, I'll share. I'll share. I'll share recordings. I'll share. Okay, thank you, everyone. Thank you. Hmm. About my research, it's about semiconductor devices. So we fabricate semiconductor devices and we use it for various purpose. So currently we are focusing more on detector purpose and this photovoltaic purpose. So these two purposes. So yes, it's going on. So we cannot say much about research. So it's going on. I hope it will go smoothly. That I can only say. So can I end? Thank you. Thank you, everyone.